Should you get a stool test? That is the question. Hello, and welcome to the SIBO SOS podcast. I'm your host, Siobhan Sarna. Today, I'm joined again by one of the most brilliant people I know, microbiologist Kiran Krishnan of Microbiome Labs. We're going to discuss a really exciting and controversial topic. It is stool testing. As you probably know, stool testing cannot diagnose SIBO, small intestine bacterial overgrowth. And if you didn't know that, I'm glad I'm telling you now. But it is useful for a lot of other things. And that's what we're going to be covering in this episode. If you've ever considered stool testing or even done it in the past and you weren't impressed with the results, you're going to learn so much in this episode. Let's go. Thanks very much, Kiran. Great to see you, sir.
Yeah, great to see you as well. I'm excited to do this. And this is actually the first public conversation about the stool test. So I'm happy to do it first with you.
Thank you. So honored. Okay. What in the world made you want to do a stool test? And then we are going to show an example report and tell us about what it is that you're so excited about.
Yeah. So, to be completely honest, I did not want to do a stool test at all. I'm not a big fan of them in general. I've seen a lot more problems than benefit from stool testing to begin with. I've had just literally hundreds upon hundreds of people sending me their tests, asking me what it means, freaking out about this one species that seems to be arbitrarily high. What can they do about it? There's no direction. There's no real solid information on the test. And then when I started really looking into the whole sequencing science, you come to find out that most of the tests on the market are using really antiquated technology for sequencing. I mean, this is technology that was developed 20, 25 years ago, right? So imagine you're walking around the street and you see somebody on a 20-year-old cell phone. Right, everybody will be laughing at them and wondering what museum they got that cell phone out of. And it's like any other technology, people are paying good money to get their microbiome sampled and tested through really old technology. And as it turns out, that old technology, which is called 16S sequencing, is actually really inaccurate when it comes down to trying to detect bacteria at the species level, or viruses or fungi. No matter what the microorganism is, trying to detect it down to the species level, it's incredibly inaccurate, to the point where, the head of the American Gut Project, Dr. Rob Knight, has come out over a year and a half ago and said that it's not useful to detect bacteria to the species level. There's been published studies showing how inaccurate it can be. And so, it just started to really bother me that people were spending their hard-earned money. They're looking for direction. They're looking for possible answers to the problems that they're having in these tests that are relatively expensive, that is completely inaccurate. And that in itself made me kind of rally against the whole idea of stool testing to begin with. 4 or 5 years ago, that the highest level of technology, which is called whole genome sequencing. So it's called end-to-end shotgun sequencing. And I'll explain what each of these things means a little bit more in a second. But the overall picture is that type of sequencing is the type that you need to really get down to the species level. The problem is it's extremely expensive. It costs over $1,000 to sequence one sample, and it's just not feasible, which means that a lab is going to sell it to a patient at $3,000. I mean, who's going to spend $3,000 to get their gut microbiome sequence, right? Now, with the advances in technology over the last several years, they've been able to get that down to a much more economical scale. And one of the labs that has been doing a really good job with that is a lab called Cosmos ID. And I've been working with Cosmos ID behind the scenes, looking at their sequencing technology for clinical trials. We've done a lot of clinical trials on the microbiome. We are doing a bunch right now, but we've never used microbiome analysis as part of it in a human trial because you can't get accurate data out of it. And so we started looking for labs that can really do shotgun sequencing with really accurate analysis, and also one that was affordable. And we found that Cosmos ID has a option for that. Now, what's important to note about Cosmos ID is they're one of the global leaders in sequencing technologies. People have never heard of them because they don't have any consumer offering. They work behind the scenes. They work with hospitals and clinics. They're one of the only labs that does sequencing that has FDA approval on sequencing identification for infectious diseases. So if someone comes in and has a mysterious illness in the hospital, they will send out the samples to a lab like a Cosmos ID that has FDA approval for their process of how to identify these organisms. And those are life and death situations, right? So they have to take the technology very seriously. Those are the things that made me really interested in them. So we started working together and partnering about 1.5 years ago, and I really got into their technology to see, does this fit the bill? If we're going to do microbiome testing, shouldn't we be doing the best version that is available at the moment? That's kind of how we came to it. You know, my position has been that it's not worth doing any microbiome testing at all that was on the market. But what I came to consistently find out is that people still want to test. And practitioners and doctors still want to test. And part of that is because the microbiome is so complicated, right? All the issues surrounding it are complicated. People want as many clues as they can get to figure out what was wrong with their system and what they're doing. How does that impact the system? Is it making the microbiome healthier, better, function better, or is it making things worse? And not all of that is intuitive. You know, some of the things that you think are good solution for your microbiome could actually be detrimental. And so people wanted to do testing. So our position was, you know what, we were bold enough to name ourselves Microbiome Labs. If there's anybody that should be doing an analysis on the microbiome, it should be us. And so we took up the mantle and said, okay, if people are going to continue doing testing, let's give them a test that can actually be helpful. Let's use the most up-to-date technology. Let's work with the lab that is the global leader in this, and let's give them data that they can actually use to shape their lifestyle, their diet, their supplementation, and doctors can use it to get a clue as to how to approach the patient. So that's kind of the short version of the story as to why this test exists in the first place. It was an unmet need, and that's kind of what we focus on, right? We do everything that fills an unmet need. So there's a number of things that are different about this test and what people have access to in the marketplace. But there's a couple of things I want to highlight for people so they understand how we took a look at this, right? So I started looking at all of the tests that were available in the market. This was about 1 year ago. In fact, a couple of our staff members ordered every single test that was on the market and went through the testing protocol themselves. So we kind of looked at how each one asks you to sample your stool. We looked at how each one packages it, how you send it in, and then we got reports back from everything, and we kind of went through all the reports to see what was useful within the report and what really wasn't. For many of them, the sequencing part was completely not usable because the information is really not actionable. So we saw a big issue there. So these are the things that we started to find as the predominant issues that we wanted to correct. The first thing is that whole genome sequencing, right? And that's really important to note. So let me explain the difference between 16S sequencing and whole genome sequencing. So imagine you've got a bacteria.
Can I just interrupt
Yep.
you? Be sure to explain what sequencing is within all of that.
Oh, sure. Okay.
Yeah,
So
okay.
the idea of sequencing is reading DNA or RNA code, right? So all of our genetics are based on a DNA code. We could take your cells from your skin or the inside part of your mouth, and we could sequence it and know your exact human genome, right? We can match people that way and figure out what your code is. The same way bacteria have a code as well. Their DNA determines which type of bacteria they are. So you can look in an entire bacteria's DNA and say, this specifically is Bacillus subtilis variety natto. All that information is there in the DNA code. Now, the way sequencing has been done before, which is what most of the tests on the market currently use, is that 16S sequencing. So what that is there are these 6 regions within a bacterial's DNA that codes for ribosomal RNA, right? Now, that in itself might get confusing, but just think about each bacteria has these 6 codes within their 2 million or so DNA base pairs, right? So you've got this genome that has 2 million DNA base pairs, and then within that, you've got these 6 regions that are together are unique to that particular bacteria. And I'll give you analogies of all this so it's easier to understand. Now, what we're doing in 16S sequencing is we're trying to identify the bacteria by finding these 6 regions and saying that, oh, we found these 6 regions, this must be this particular bacteria, right? Now, the problem with that is you may never find all 6 regions. A lot of these reports are giving you a call on which bacteria is present in your system by finding 2 out of the 6 or 3 out of the 6, and then they're taking a guess on the rest of it. In addition, numerous bacteria may share a few similar sequences. So it becomes hard to tell whether this sequence structure is one particular bacteria, or is it being shared by numerous bacteria to actually specifically identify one group. Now, let me give you an analogy for all that so it actually becomes more digestible. Think of identifying a person, right? Look at Siobhan. You all know exactly what she looks like if you look at her as a whole. Now, imagine I did a close-up picture of the tip of her nose, a close-up picture of a part of her shoulder, a close-up picture of her kneecaps, and a close-up picture of one of her toes, and another close-up picture of the back of her head, right? And then I sent you these pictures, and I said, identify this person. Now, what are your chances of figuring out that that actually is Siobhan? It's tough because the tips of many people's nose look the same. Siobhan has a look on her own when you look at her in high definition collectively, but the very tip of her nose looks very similar to probably lots of tips of noses. The same thing with the small portion of her shoulder or the back of her head. You can say, hey, it's someone with dark hair, but it doesn't necessarily mean it's Siobhan. So you can narrow it down. It's definitely not a blonde. It's definitely not a redhead. You know, it's definitely not somebody with white hair. It's somebody with dark hair. So you've narrowed it down, but you can't tell that that's exactly her. So that's kind of what's been going on. You're getting these very specific snippets of DNA from these organisms, and then they've got an algorithm that's making a guess as to what organism that is, right? And that is really problematic, especially when you want to get down to the species level, right? Now, with those pictures of Siobhan, you might be able to tell from just the back of the head, the way the shoulder is, the way the nose is, that it's a woman and not a man, right? So you can delineate that. You can go, I am 98% sure it's a woman. Okay, and you're probably right. But which woman it is, how old she is, what race she is, what ethnicity, all of those things are going to be really wild guesses. And so that's the same thing with bacteria. Because you can pick up 1 or 2 of those snippets, you might be able to tell general category of what type of bacteria that is, but getting down to the species level is going to be very hard and typically very inaccurate. So that's what we're finding. Now, whole genome sequencing is we identify a bacteria only if you read the entire genome of the bacteria. You're reading the entire code. If the entire code is there, then it's unmistakable that it is that bacteria. So the analogy there is sending you a high definition picture of Siobhan as an entire person. Then it's unmistakable who that is, right? You're not going to mistake it for somebody else, maybe a beautiful actress maybe, but outside of that, you know that it's Siobhan, right? So that's the analogy there, is that we're taking snippets where we might be able to pull out some detail and make a guess versus a high definition, unmistakable image of who that is. It's the same thing with bacteria. So that's really important to understand in the differences between whole genome sequencing and 16S. If whole genome sequencing could not be made affordable, we would never do this test. We would never launch a 16S test. To us, that does not have the utility. Now, the other problem that we found is how some of these things were sampled, right? So when you look at stool, the bacteria in stool is not homogeneous, which means that you don't have the same distribution and relative abundance of bacteria in every part of the stool. So the stool is a 3-dimensional object. the surface of the stool has different bacteria than the inner part of the stool and perhaps in the bottom part of the stool. And you could take any different area of the stool and you might get slightly different distribution of bacteria. So many of the tests that we went through had us swiping the top of the stool or taking a little spoonful. They send you these tiny little spoons, taking a little spoonful of the top of the stool. Some of them even just have you swab your toilet paper, which is really problematic because the issue there is when you wipe, you're picking up a whole bunch of skin cells, human skin cells as well. So when you sample and swipe that toilet paper, you're picking up human DNA. And that's one of the biggest drivers of inaccuracies in DNA sampling is contamination with other species DNA. So now you're sending in a sample that has some of your microbiome's DNA, but it also has a whole bunch of your own DNA. Right, that's one of the advantages of doing fresh stool that has dropped into a device rather than sampling your rear end or toilet paper, is you're picking up very little human DNA as a contaminant. So looking at all that, we said, okay, what we really need is a coring system, meaning if you have a three-dimensional stool, we need to be able to get a sample going all the way through and back up. And as we're coring, we need as much surface area as possible to pick up as much DNA as we can by going through the sample. So that's why we developed this thing called the high contact coring system. So it's a brush type system that you would use and you would core through the sample and you would bring it out and there's hundreds and hundreds of bristles on the brush and it picks up maximum amount of DNA and samples from your stool sample, right? So that was another advancement that we wanted to make. Now, the other thing was the microbiome mapping. Mapping is really important in that we need to understand where we are in terms of the general properties of our microbiome compared to a really strong sample of U.S. healthy population. Right. One of the advantages that Cosmos ID has is they have data on hundreds of thousands of stool samples, and they can delineate like these are stool samples of people with Crohn's. These are people with diabetes. These are all of the healthy population. And so what we want to do is provide you some mapping to see what aspect of your microbiome is totally off from where the general U.S. healthy population is, because this will then give you a clue as to what the most important thing is to work on for your microbiome, because there's lots of things that you're going to have to work on when it comes to fixing your microbiome, but we wanted to be able to prioritize it. So any of the things that map way off the chart from hundreds of thousands of U.S. healthy population samples are the things that you need to give priority to in order to repair. And then the last thing is functional reporting. Right? Giving you a list of just all the species that are found in your microbiome sample means really nothing, right? What we wanted to do is focus on what functions your microbiome seems to have the capability to perform and what dysfunctions it has the capability to perform. Because really at the end of the day, your outcomes, your symptoms, your conditions are based on the types of functions and dysfunctions your microbiome performs. And many of those functions and dysfunctions are not based on a single species that are found in your microbiome. Many of them are based on groupings of bacteria that conduct those particular functions. So we wanted to give you a full functional mapping based on everything that's known now, and that'll keep changing as we go along because we're learning more about the microbiome. But we wanted to give you a full functionality because that will really tie back to the symptoms you're having, to the problems that you're facing in the foods that you've tried, in the supplements that you've tried, in the lifestyle changes that you've tried. It really kind of gives you an understanding of the functionality of your microbiome. So these four things are extremely important in really getting the most accurate data, maximizing the amount of capture, and then understanding where you fit compared to a healthy U.S. population and what functionalities your microbiome performs and doesn't perform. So that is the general outline. I hope that made sense, Siobhan. Are there any questions you think about that in particular?
We have questions, of course. Hey, Summer. Hey, Pam. Okay, so Pam says, can you tell if it's a pathogenic amount of bacteria or yeast or just if it's present? So the pathogenic cutoff.
Yes. So so this is important. When we look at the sample report, I'll show you one section of it that looks at something called your pathobiome. Your pathobiome really gives you an idea of what the relative abundance are of various pathogens compared to the rest of the microbiome, right? And that's important. And it compares you by providing an index, which has a statistical calculation in it compared to the typical healthy population. That in itself will give you an idea of, are pathogens really a problem in your microbiome or not, right? Because just seeing the presence of a pathogen or 2 or 3 or 50 doesn't necessarily mean that they're a problem, because it's completely normal to have a variety of pathogens in your microbiome. So one of the problems I've had with the previous tests is they'll just show you these pathogens and give you this +2, +3, tell you something's high and something's low, without any real statistical analysis of the entire pathobiome index compared to the rest of your commensals and compared to the U.S. healthy population. Because then what people became fixated on is they see one pathogen at what these tests would call high, and then they're fixated on, how do I get that down, right? So in most cases, you may not need to do anything about pathogens, but you won't know that until you look at your pathobiome index. So that's one of the things, and we could show that on the report.
So because everybody, even healthy people, have E. coli, right?
Yeah.
Right. So we don't want to get overly focused on, oh my gosh, it's in there. Some people do fine with parasites. Not me. I understand it sounds insane, but some people have found a symbiotic, peaceful relationship, are totally healthy. They do a stool test, they have parasites. Other people are suffering terribly. You do a stool test, there are no parasites. So it's so individualized. No one likes to hear that it's individualized, and yet it's the ultimate individuality. It's your microbiome DNA. And what's happening?
It is. And so the only way to look at it is looking at the statistical index of your pathobiome load relative to your commensal bacteria, and then also relative to the pathobiome load of your average healthy American. That is the only way to look at it, to see, is a pathogen really a problem for my microbiome?
Okay. For those with SIBO, how will this aid in managing?
Yeah. So here's a big thing with SIBO, right? So it's not really going to tell you much about what's in your small bowel. So that would be overreaching, and the technology doesn't do that. But it will tell you how messed up your large bowel might be, and where the significant issues are.
I'm sorry, I'm laughing. Yeah.
And the thing is, so much of SIBO is driven by just overall microbiome dysfunction. I've done talks on this group specifically saying that, we really focus on what's overgrowing in the small intestine without really looking at all of the other dysfunctions that are associated with SIBO. And one of the big ones is leaky gut. And you'll be able to tell, are you producing too much ammonia, for example? And if your SIBO diet now consists of high levels of protein because you're not eating fermentable carbohydrates, then if you have high ammonia producers in your microbiome, you're converting so much of that protein to ammonia. And that's going to continue to stress your liver. And when that continues to stress your liver, you produce less bile. And when you produce less bile, you become more susceptible to SIBO. Right? So there's lots of connections to how the rest of your bowel functions, what the rest of your microbiome looks like, to the symptomatic condition of SIBO.
And big picture, which is obviously what we're talking about here, but I'm glad we talked about that aspect of it. Like, I'm literally doing a summit in September called the Microbiome Rescue Summit, from SOS to Rescue, because it's not just about the gut. Obviously, everyone here knows this. It's about your mental health. It's about your hormones. It's about your entire well-being, right? So So SIBO patients were so tunnel vision. I get it. That's why I started SIBO SOS, because I couldn't think of anything else to do. Even though I had a full-time career, I was obsessed with it. So this is beyond just SIBO as to why anyone would want to know what's going on in the microbiome. So we do have
it's your overall health, and the thing I say about it, and you can't, even when you have SIBO, it's very easy to get focused on the small bowel and what's going on there. But, what's worse than SIBO? Colon cancer.
Yeah,
right? So we can't ignore these other things, right? When we become very focused on that one component. So it's really important to keep looking at your overall health. Absolutely.
1000%. I'm sure everyone would agree with you. But I think it's really important because a lot of people who are new to SIBO don't even know the difference between their large intestine and their small intestine and what that means, which is totally fine because we all started somewhere. And so it's really, I'm so glad we're making these refinements and these refinements in knowledge. Okay. Cool. It's an amazing tool. Walk into your doctor's office with it. Oh my gosh. Of course.
Totally.
Nutritionist office with it, right?
Absolutely. So then the next part is we're starting to look more into the functionality of your microbiome, and part of the functionality of the microbiome has been the identification of ratios of different groups of bacteria within the microbiome. So this one is one that a lot of people have heard about, the Firmicutes Bacteroidetes ratio. That has a lot of implications on metabolic health. The increased Firmicutes Bacteroides ratio, meaning a larger number, higher amount of Firmicutes, has been associated with obesity. There's general associations with incidence of pathological and chronic inflammation with different aspects of this ratio. All of that is explained there. We talk about, how certain lifestyles can impact this ratio. And then if the ratio is outside of the healthy normal based on those 100-something thousand samples, you can do things here based on the nutrition lifestyle recommendation to modulate that ratio. And all of these things can absolutely be modulated. The other one is the Proteobacter Actinobacter ratio. That has implications for people with metabolic disease, cancers, and obesity. So these chronic conditions are ones that you're concerned about. This ratio is something important to pay attention to. And then, of course, if the ratio is off outside of the healthy range, then here are some recommendations as well. So looking at some of these, the impact of these ratios kind of gives you an understanding of, okay, if I'm totally right in line, then this is not really affecting me in any major way. Same thing with Prevotella bacteroides. This, again, has a lot of implications with metabolic disease. It has protein, animal fat implications, like dietary implications with intake of high protein or high animal fat levels. And it changes the prevalence of certain groups of these bacteria, and that has potential outcomes for your overall health. My dog is really excited about this particular one. So let me shut the door. Okay. So those are the most important known ratios within the microbiome that actually have an implication on health outcomes. So that's why we look at those. Now, there are other ratios, but there really isn't much science behind how they actually impact health outcomes, what symptomologies they're associated with, and so on. So we didn't really focus on those. We're really looking at things that have been pretty well established to have an impact on health outcomes. So those are the ratios. These are the big general groups of bacteria and where they are in reference to one another, and then what implications those have, and then, of course, what you can do about it as well. Now we get more into the specific functionality within the microbiome. So we talked about biologically important bacteria in my gut, and this is where some of the function and dysfunction of your microbiome really comes into picture. The first one, for example, is ammonia-producing bacteria. And we look at the number of bacteria relative to the rest of your microbiome who have been known to produce ammonia. They convert proteins and carbohydrates into ammonia preferentially over other postbiotics. Now, these are really important because ammonia is a major source of stress in your microbiome, and then also in your liver, and then ultimately in the blood system as well, because it changes the pH, it creates toxicity, it creates liver distress. And so what we talk about here is if your ammonia production is high and ammonia clearing is low, here are some nutritional guidelines and some supplements to follow, because you may have high ammonia producing bacteria, but at the same time you've got high ammonia clearing bacteria, then your net ammonia gain is very small to nothing. right? But if you have high ammonia producing bacteria and low ammonia clearing bacteria, then you've got a problem with ammonia in your system. Now, one of the things that's interesting with this is, taking in more protein, more amino acids, if you're high ammonia producing and low clearing, actually is detrimental to your system in general. Your liver health, the rest of your microbiome, the health of your large bowel, the pathogenicity within your blood, all of these things have an impact. Your brain health, all of those things are impacted by the number of ammonia producing bacteria, and if you're taking in higher levels of protein. So although many people assume a high protein diet is a good thing, for people with high ammonia producing bacteria, it's actually not. It can actually be quite toxigenic. You wouldn't really know that until you had an analysis like this done, right? So that's one of the functions. Another one is,
one other thing, Donna Gates is doing that DNA summit right now, and she talks about ammonia clearing in your pathways. So there's the bacteria that can help clear the ammonia, but also your pathways for those of you who've had like your DNA analyzed or are thinking about it. So just wanted to throw that out there.
Yeah. And then the other one, estrobolome. Estrobolome is really important, especially for women. It's a network or constellation of bacteria whose job it is to metabolize estrogen. People who tend to have low levels of estrobolome tend to have estrogen-dominant conditions like PCOS and higher risk for estrogen-dominant cancers and so on. And then you've got high levels of beta-glucuronidase activity, which is implicated in certain types of pathogens within the system. And so we go through what your estrobolome levels are that have been picked up, how you can improve your estrobolome, and what the implications are of this particular constellation of bacteria. And I don't think anyone is testing estrobolome right now, and there's lots and lots of issues and questions people have about hormone balancing, especially women with estrogen balancing. This will give you a lot of clue into what's going on within your microbiome with regards to estrogen. Sulfate reducing is really important. So sulfate reducing is a group of bacteria that will actually reduce sulfate into hydrogen sulfide. Sulfate comes through your diet in many types of foods, and having a balance in sulfate is really important. But a lot of people will tend to have a high level of sulfate-reducing bacteria. Now, for those people, eating foods that have high sulfate in that can be really problematic. And many of these things are foods that we would assume to be very healthy, things like seafood and eggs and apricots and peaches and onions and garlic and cabbage. These are all foods that tend to be high in sulfates and sulfur, sulfates in general. And then if you have high levels of sulfate-reducing bacteria, these particular microbes are converting that sulfate that's coming into the food into hydrogen sulfide, which is toxigenic and inflammatory to your large bowel. And it's also clearly and closely associated with irritable bowel syndrome, small intestinal bacterial overgrowth, and different forms of IBD, right? So inflammatory bowel disease, irritable bowel syndrome, and so on. So this is really important because you might think, okay, eating, some clean fish, eating some eggs, eating some spinach, some asparagus, some bok choy, broccoli, those are all really good, healthy foods, right? There's nothing wrong with the foods themselves. But if your microbiome has gone through a shift where you have really high sulfate-reducing bacteria, then these seemingly healthy foods could be quite toxigenic to your system. And you may be frustrated because you might have changed your diet. You might have added in some of these seemingly healthy foods, and you're not getting better, or your symptoms might even be getting worse. This might be a clue as to why that may be. That's why these kind of functionalities are really important, because we really need to understand how the choices that we make can impact the results that happen within the system. And you only know that when you understand the types of microbes that are prevalent in the system. That's the same thing with methane producers. Methane producers will utilize substrates and convert them to methane much more dominantly than other bacteria. There are certain nutrition that can actually negate that. For example, some people are low sulfate reducers, but high methane producers, and often they go opposite to one another. And so one of the ways of actually reducing methane production is to increase sulfate reducers, and vice versa, right? So this report will kind of give you an idea of where you stand in that comparison, and then what are some of the things you can do for diet and supplementation and even lifestyle to balance those two out. Now, there are a number of other functionalities. I'll show you a list of them, but this is the 1.0 version of the report. The other functionalities aren't quite ready, but what's important to note is that when you send in your sample now and get it tested, you'll get this report. But when the other functionalities are ready, they're going to rerun your sample, the one you already sent in. You don't have to do another test, and then send you an updated report with the updated data too. Some of the other things we wanted to look at is functional keystone species, right? So these microbes are considered to be keystone because as a singular organism, they play a very important role in maintaining not only the health of your microbiome, but the overall health of the individual. And we've talked a lot about a lot of these in a lot of talks. So we wanted to be able to measure it for people to tell them where they are with their important keystone species. So Akkermansia, Muciniphila, Faecalibacter prausnitzii, Rhumnococcus bromai, Rhumnococcus flavifacens. So there's a number of identified keystone strains. We talk about what their function is, like in this case, cellulase degrader, B-mannan degrader, and butyrate producer for Rosebaria. And then again, if their keystone strain is low, then we give you both nutritional and supplemental recommendations for how to increase the growth of those particular keystone species. Bifidobacterium longum is important because it's an acetate producer. Acetate is really important in maintaining low pathobiomes. It also is really important for the liver, for the brain, changes to the skin, and so on. So all of these keystone strains play an important role. It's really important to know where you stand with regards to the keystone strains within the microbiome. Then these are the other functionalities that will show up on the 2.0 version of the test. So saccharolytic fermenters versus proteolytic fermenters. This is important because, you would assume that eating a high carbohydrate or high resistant starch or fiber diet is a good thing. Well, it's not necessarily a good thing if you tend to have high proteolytic fermenters because they will convert the carbohydrates and the resistant starches to ammonia and other gases, versus saccharolytic fermenters will convert it to short-chain fatty acids. So understanding where you are in that spectrum is really important to modulate your dietary intake. Vitamin, mineral, and digestive enzyme producers within the gut. Histamine production. A lot of people have histamine intolerance and issues around histamine. This will give you a clue as to the level of histamine production within your microbiome. Indole production is also important because that balances out histamine. And so if your indole production is low and your histamine is high, how do you rebalance those functionalities? You'll get that information as well. Hydrogen sulfide, then some really important neurotransmitters, serotonin, tryptophan, GABA production. Do you have adequate microbes that produce these really important neurotransmitters, the vast majority of which have to come from your gut? That gives you a clue as to the, some of the digestive symptoms, the overall inflammatory symptoms, and then, of course, all the cognitive symptoms you might be dealing with as well. Acetocarnitine, L-carnitine production, secondary bile salts, all of these things are really important known functions within your microbiome that directly correlate with risk for certain conditions and or symptomology associated with specific conditions. So those are really important to know and understand, and again, speak to the functional aspect of your microbiome. And again, for everything, we will be providing actionable steps if the prevalence of this is off and is off from normal healthy levels. So that gives you the overall functionality of your microbiome. Now, the next few pages gives you a different way of visualizing where you are compared to U.S. healthy population. This is just overall composition at the phylum level. Phylum are the biggest groupings of bacteria. It's all color-coded so you can see how dissimilar or similar your color coding is from the U.S. healthy population. This, again, looks at percentile levels of certain groups of bacteria compared to U.S. healthy population. A lot of this is what was reflected in the very first page to give you your whole microbiome index. This is just another way of visualizing it. So it gives you that additional information to look at and gives your doctor additional information to look at as well. And then the next part, so that goes into a little bit more detail. These are all, again, where you map compared to a healthy population. And then one of the things we're throwing in is just kind of unique species that are found in your sample that aren't typically found in a U.S. healthy population. Some of these might be completely, really rare species that may not have been found in any other sample except for yours. And then you can always Google these and kind of look and see what they're up to. But that's one of the things we want to throw in there. How relevant is it to your health and overall wellness? Maybe not, but it's just one of those interesting things that we wanted to throw in. So that gives you an overview of the kind of information you'll be getting in the report. It's important to map your overall principles and functions of your microbiome to where the healthy population is. It's really important to understand where your pathobiome is. It's important to understand the various aspects of diversity, the resistance genes, and so on. Then you get into the importance of the keystone strains. For the first time, you'll be able to see where you map with regards to the amount of keystone strains in your microbiome. And here's one of the things that research shows is loads of chronic issues can be helped just by increasing one or two keystone strains within the microbiome. So that's how powerful they are.
Can you explain what a keystone strain is? And then I have a slew of questions for you.
Yeah. So keystone species are basically species that tend to either A, play a significant role in maintaining the rest of the microbiome, and or B, have direct correlation to implications of health and wellness in the host. For example, Akkermansia muciniphila is inversely correlated to everything under the metabolic syndrome spectrum, right? So diabetes, cardiovascular disease, dementia, polycystic ovarian syndrome, hypogonadism, which is low testosterone in men. All of these things are inversely correlated to the amount of Akkermansia you have within your system, meaning the lower the Akkermansia, the more susceptible you are to those conditions, and which means that Akkermansia protects against those conditions. Same thing with Faecalibacter posnitzii. It's a keystone strain that has been shown to protect against inflammatory bowel disease and other inflammatory conditions within the bowel. The higher Faecalibacter you have, the less risk you have for inflammation in the bowel. So these keystone species are so important that on their own, they can be a complete solution to a health issue. And you wouldn't know where you stood with the keystone species until you do a test like this. And you go, you know what, a lot of my problems may be coming from having really low levels of Faecalibacter posnitzii. Everything else seems to be okay, but Faecalibacter seems to be really low. That's what I'm going to focus on first, right? One of the problems I see in functional medicine in general, especially with the microbiome, is people do too many things at once, right? You're throwing in lots of things into the system at once. You don't really know what's actually working. You're not going about it in a stepwise manner. This also kind of helps identify, like, okay, here are the priorities that you should be looking at. These are the things that are way off, and those should be the things that you're focusing on right off the bat.
I've got a couple of very specific questions for you. One is from our dear friend Summer Bach, who is an expert in fermented food. If you ever want to know what to do to make fermented food, go find Summer Bach on the web and Facebook. She says, which bacteria eats acetone? I see a lot of clients with high acetone and low bifidobacterium.
So acetone or acetate? She said acetone.
Acetone is nail polish remover, so that's my filter. Right. Sorry. She says acetone too, but we mean acetate.
Acetate, okay. So lots of the butyrate producers will consume acetate and convert it to butyrate. For example, Faecalibacter is one of them. Rhamnococcus is another one. Subtilis can as well. Acetate is really important and needs to be produced. As I mentioned earlier, it has a function in the liver, it functions in the brain to some degree. You find acetate in the blood. Acetate also is a good antimicrobial and actually keeps low levels of pathogens in the system. But then when you have your butyrate producers, what they do is they start consuming the acetate and converting it to butyrate, which ultimately is the thing that controls metabolism and so on. So some of the keystone strains that are identified as butyrate producers, most of them will metabolize acetate.
Okay. Is this available in the UK?
Not yet. We're trying to figure out how to make it available in the UK. We're just kind of looking at some of the regulatory things and then also the shipping of the sample back. We're hoping that it will be by mid-year.
Okay, so and the rest of Europe, or so right now, let me rephrase it. Is it only available in the US?
Yes, exactly. So the next regions that we're looking at would be Canada and the rest of Europe, including the UK, and then New Zealand and Australia as well.
Great. And then also that 2.0, that extra set of markers that you were talking about, that will be available to people even if they're just doing it now, and then when the second set is created and you can run the test through. When is that happening?
So we're hoping that the 2.0 version of the report will come out sometime in the next 2 months, 2 to 3 months. So you can get all this data now, and then when that data is available, it'll just be automatically sent to you. And then you can look through that and kind of get more clues from that. But you could start your programs and figure out what you want to do therapeutically just based on this data here. And then when you get that information, it'll give you even more clues as to what may be dysfunctional in the microbiome.
Very cool. So Alex from your team has sent me a video to share with everyone about how to order. And one of the things he said was, you actually don't get it sent to you guys. You go to the portal and download the information.
Yeah.
So I want to be clear with you about that. You can order the test online. This is a favor that Kieran is doing for SIBO SOS, that if you go through My Patient Direct using code SIBO SOS, you can order directly. We're the first. Otherwise, you are going to your practitioner, which of course I always recommend and suggest. Maybe you don't have a practitioner right now. You can download the results, take it to a practitioner as a great starting point of a conversation. If you don't have practitioners, go to the SIBO SOS Facebook group. There are tons of people in there who can help you with their own personal referrals.
Yeah.
Okay, and the cost is $399. And I will, if you're not on our email list already, then definitely go to SIBOSOS.com and opt in, fill it out, the little form. You'll get a free SIBO cookbook, and we will email you this information with the little video that Alex just sent me about how to order, and this video, but it'll also be in the video section here in Facebook, and the patient code. It's an elegant, simple way to order, but there are a couple of little things that I'm afraid might trip you up. So you do want to watch that little quick video beforehand. Okay, and how long does it take to get results, Kieran?
So at the moment, it's going to be about 4 to 5 weeks, I believe. And we are working hard to push that down to 3. 3 would be amazing, but it's about 4 to 5 weeks right now.
Yeah, okay. What else? Let's see. I think, so somebody did have a question about Candida, just as we're sort of wrapping up. Does it cover different Candida strains?
It'll pick up whatever different Candida that you have in your system, yes.
Okay. It's not available in the UK yet, Jeanette, but it's coming. It's coming. They're hoping within the next, 6 months to a year? I know it's a little...
Yeah, by mid-year, we want to have it available there.
Okay, great. Okay. Let's see. I know that somebody just asked a really great question. I wanted to answer with you. They're saying, when changing diversity in the gut, hey, Roberta, when changing diversity in the gut, should we even be concerned if it feeds the SIBO bacteria? I have a comment about that. And Kieran, I want to know your comment about that. That's where you really have to work with your practitioner. You have to figure out the order in which you're going to treat things. And that's why they say don't stay on the low FODMAP diet long term, right? Because you lose that food for the diversity. So it's a really insightful question, Roberta. I think it's such a personal decision and has to do with where you are on the SIBO recovery roadmap, right? Where you are in your process. What do you have to say about that?
I totally agree 100%. I mean, we know that diversity is paramount to health and overall health. So it depends on where you are in terms of like, I want to fix this SIBO problem right now versus I'm looking at my overall health as well. You know, and so where you are on that spectrum will determine what approach you take, and maybe that's a conversation you have with your health practitioner to figure that out.
You are amazing, sir. We so appreciate you. Thank you so much.
Thank you.
Really.
Yeah, it's been a pleasure. I'm very excited for people to really get to know their microbiome by doing this test. I'm excited to get to know my microbiome for the first time as well with this particular test. So. You know, I'm excited for people to try it and see, you know, it's going to really provide people some really interesting direction. And that was the intention here when we started looking at the problems from most of the tests available on the market. So thank you for this opportunity to talk to your audience about it. And it's an exciting year for us to look at this. And then by the way, we're also using the test in a couple of clinical trials that we're doing right now. So, you know, we'll have actual clinical data supporting the functionality of the test as well.
So Kathy's asking, and so is Marion, do you need to stop taking any supplements or medications before doing it, and for how long? Because I think we're used to that.
You don't.
You don't?
Yeah, to me that doesn't make any sense at all, because I want to know what your microbiome is like now, including all the stuff you're doing, right? And so when you stop doing all the stuff you're doing and your microbiome starts to change, what's the value in knowing what that looks like, you know, versus what it actually looks like and functions like when you're doing your diets and your probiotics and all that stuff. So, yeah, you don't have to stop doing anything. You know, I wouldn't go and do like a colon hydrotherapy the day before you do it. You know, just make sure it's part of things that are part of your normal routine.
I think that's such a good point and a really powerful way to wrap. You know, I've talked to a lot of people, and the questions always happen, and I've talked to you about this, is like, do you have to be on a probiotic long term? Do you have to take one every day? And somebody, I can't remember who, but somebody really smart said, well, every day you would have been going out to the yard or the garden and picking your potatoes and your carrots. So every day you were inoculating your microbiome. You're not feeding your microbiome with a supplement or things like that, or fermented food even. You're constantly feeding it and fertilizing it, right?
Yep, exactly.
Okay.
So, and we need to know what your microbiome looks like at that moment, right? And all the functionality associated with it at that moment, and what you're taking as a supplement, what you're eating, all that has an impact. So yes, absolutely. You don't have to stop anything. You don't have to get off of anything for weeks on end to test your microbiome.
Thank you so much to Kieran for graciously sharing his time and his knowledge with us again. I also want to make sure you know that Kieran has given our community a special way to get the famous Megaspore and other Microbiome Labs products at a 15% discount on your first order. Now, normally you'd have to go to a practitioner's office to order these products, but the SIBO SOS community, which you're now part of because you're listening to this podcast, can order it directly just by registering on microbiomelabs.com with the patient direct code SIBOSOS. And then you can use your code DigestionSOS at checkout for the 15% off your first order. So make that first order count. I'll put the details in the show notes, as well as other exclusive discounts we have just for our SIBO SOS community, as well as upcoming events. I'm Siobhan Sarna, and see you next time. Thanks for being here.